Yep, you're good now. I'll go back on mute.
Okay. Okay, cool. So yeah, StorageOS and NATS. So this webinar will mostly be about how we use NATS, not about StorageOS or how we provide storage for containers. So I'll just shortly cover like what is StorageOS in itself. So as I mentioned before, it's a storage for containers. What it provides more than just mounting a disk from a node is that you can mount like any volume on any node from any node. So if like containers are moving across the cluster, you don't actually care about data because it's always available, always there. Then it provides replications, so nodes can go down. That's not a big problem because data can be replicated, then synchronized to new replicas. Then it's what's also important about it, it's only a single container. It doesn't have dependencies. It doesn't have like a separate database. So it's like super easy to deploy. Like, and we are currently in a process of releasing 0.8 release that will have embedded etcd. So in a current version, that's official one, we use console. But as we noticed that a lot of people are having problems setting up KeyValueStore like separately, so we decided to use embedded etcd in this case. And it also integrates natively with Docker and Kubernetes. So with Kubernetes, we managed to merge our plugin integration in 1.7 release, and from then it's available. Okay, so architecture of StorageOS. Well, basically there are two components. One is written in Go, it's control plane, and then we also have data plane on the left side. So data plane is mostly written in C. A bit of it is in C++. I mostly work on control plane. Control plane has provides REST API for CLI, UI, plugins like Kubernetes. Then it has internal scheduler for like placing volumes, ensuring replication, ensuring health of the cluster. Then it also has inbuilt serve, NATS, etcd, and supervisor. So basically, control plane runs data plane as a supervisor. We chose this strategy of embedding as many things as we can into like a single product because it makes deployment a lot easier for customers, and same for us because we can programmatically manage configuration. Like for etcd, we create like initial cluster member list automatically in control plane, so users don't have to specify that. Same for NATS. For NATS, we run a server on each node that connects to other servers, and NATS client only connects through the local host. And through a mesh networking, it just discovers all the routes. So it has quite a lot of things, and everything is in a single binary, and then in a single Docker image. How we use NATS in the first place. I think initially we started using NATS because it just made sense for simple tasks in a cluster where event can come, initial event like HTTP one can come to any endpoint, and then the cluster would have to be notified about it. So for example, a user creates a volume, and then all the nodes have to get specific configuration. So any node can access any node from anywhere. Then also like really simple to implement like schedulers that just receive events from all the cluster nodes, and also they can send events to all the cluster as well. So when I compared NATS to, for example, NSQ, I really liked like this higher level functionality that NATS provides, like request reply. So it feels like more like RPC than pops up. which is kind of, well, adds a lot of value for these systems that we were working on. And see, for like drivers, like each node can subscribe to specific queue, and if you have, well, unique IDs for nodes, you are well aware how to actually deliver any event to any cluster node. This is like a high-level architecture of how NATS interconnects everything inside StorageOS. So like here we see like multiple ways of interacting with StorageOS, like Docker plugin, Kubernetes plugin, CLI, UI. Everything goes through HTTP initially. Well, in Docker case, it goes through a Unix socket, but it's pretty much the same. When requests hit REST API, in some cases, configuration can be written directly to etcd, because all the nodes would be aware of it. So like in some cases, you don't need to notify other cluster members about like something has been added or removed. So for example, if you just add some labels to volumes or remove them, or add like rules, you don't need to inform all the nodes. But in the most important cases, you kind of need to access a specific node from anywhere. So in this case, a scheduler is running on a single node in the cluster. So we use etcd logs to acquire leadership. And once a node becomes a leader, it starts a scheduler, and scheduler subscribes to multiple queues like volume create queue, volume delete, update, and so on. And then, like any request coming to any node will be delivered to the node with a scheduler. And same goes like the other way around. When scheduler is finished with well, evaluating cluster for like new volume creation, it sends event to all other nodes, all other node drivers to write configuration. That configuration is then picked up by the data plane, and then it's ready to accept like mount requests and just pass through data. This really worked great for us, and it still works. We probably started work on this more than a year ago, way more than a year ago, right from the start, and then we just continued building on top of NATS. We started initially with like a separate server for NATS, but eventually we saw that NATS server is like really lightweight application, so you can just spin it on a separate Go routine, and you are good to go. And it's very easy to configure as well. Okay. So advantages of this architecture. So as I mentioned several times before already, is that the main thing for us using NATS is that any node can reach any node in the cluster. Then the second point is that clients only have to connect to the local host, and the servers are doing like the mesh networking. So it really simplifies configuration. So for example, the workflow here is like each node registers to Kivalo Store. From Kivalo Store, we get like a list of nodes. We supply that list to NAT servers. They create peers, and mesh is established, and any client can now talk with any node in a cluster, which is like really useful. Also, by knowing IDs of the nodes, you can use request reply. So like some users, and in some use cases, you don't want just a simple pub sub where you fire and forget, but sometimes you want to get reply. So you know, for example, that certain operation has failed. In our cases, we want to know when the drivers fail to write configuration. So for example, if the scheduler creates like a master and replica volumes, and we failed on the request that, for example, writes replica, we probably want to fail whole volume. So it's very useful to have like a simple way to know whether a message was delivered or not. In other messaging systems, it's usually being done by like generating a unique topic ID, sending it with a message, and then the recipient can actually reply to that generated ID. Well, it's pretty much the same thing that NATS is doing under the hood. It's just you don't have to write it on your own. So big plus. Okay, using StorageOS. Currently, it's a single command to run a new container with a StorageOS volume. So I'll just want to show what happens when that single command is executed. Like, installation is simple, won't be going to that. Just want to show request journey. So in this case, Docker is communicating over Unix socket to our Docker plugin, which is running there either when you are using storage plugin installation or when you are using just node installation. So it's pretty much the same. Like, Docker runs in both cases our image. So first thing that happens is we write initial volume configuration to kValueStore, and then publish event on NATS that the scheduler will pick. Once scheduler picks that new volume request, it schedules a volume on a available node. If it's possible, then it will schedule on the same node that the Docker container requested a volume, so you can get like the same performance as you would be getting from a local machine, which is great. If it's not possible to do that, it will just schedule it where it's possible, or it will fail if you don't have like any storage left. Either way, you'll, well, in the first two cases, you'll end up with a volume somewhere in the cluster, hopefully in the same node, and therefore volume status will be updated to active. And once the volume status is active, then we can actually return mount path to Docker. And Docker just thinks, okay, I've got a volume that's available locally, I'll give it to a container. So I can show you a quick demo of how it looks like. So, okay, here I have a 3-node cluster with our current pre-release. I have 3 nodes here. I'll just run a new container, Redis, with append only, so it writes everything to file system. I'll specify volume driver StorageOS, and hopefully it's created. Yes. Now, if I check, not sure how well it is visible. Yeah, so now we can see that the volume was created. In our product, StorageOS supports multiple namespaces, but since Docker supports, well, it doesn't support namespaces currently. It might be adding something similar in the future. We use the default one. In Kubernetes, it would be whatever namespace your deployment is using. It automatically created that volume, and it also shows that it's mounted on the node 1. What we could do here is we could remove that container. And now we can see that it's not mounted anymore. So volume is still active, data is there. What happens is that when you are deleting a volume well, not volume, when you are deleting a container or just stopping it, and Docker unmounts it, so then it can be mounted anywhere else. So for example, if you're running Swarm on a Node.js, it would be removing all the containers and releasing all the volumes. So now we can actually use the same command with the same volume name on another node. Here we mounted it again. And if we look at volume ls now, it shows that it's mounted somewhere else. So even though location is StorageOS node 1, it can be accessed by StorageOS node 2. In this case, all the traffic will be going over the network, which is slightly worse than locally, although our data plane protocol is designed for low latency, small packets transport. So it wouldn't be a big problem, especially like for database, because that, well, it was built for that. I think the main point here is that data can then be moved. So in a 0.9 or later release, we'll be adding data locality, where control plane can actually move data with the container wherever it's mounted. So that's pretty much it. So it would be good if we could get some questions. And yeah, thanks for joining this webinar.
Cool, thanks, Karalis. I saw a few questions come in, so I'm just going to go through them in order. And then if anybody, as I'm asking them, if anyone thinks of any other questions or things, you want to know about based on what's covered, just go ahead and type those in. So let's see what we've got. All right. So I think you mentioned NSQ, but there was a question. I don't know if that's the only one. There was a question, hey, what other options besides NATS did you consider? And what were the drawbacks with some of the other options you looked at?
Okay, yes. I think it's kind of related to the blog post that I wrote some time ago. So other options that we looked at were gRPC and, well, NSQ as well. So what I found a bit wrong with NSQ was that it was heavier when compared to NATS. Like the standalone server itself wasn't as easy to like just spin on a separate Go routine as it was with NATS. And it also lacked these higher level functions like request reply, which I really found useful, well, in NATS. With gRPC, there is another problem like creating this mesh network. So if you would want to achieve something similar like you have with NATS, but in gRPC, you would have to create like connections between every node to every node. Maybe that wouldn't be that difficult, but it's still like more connections. Or you would also have to create some kind of like central, well, like a scheduler that would be making sure that messages are delivered everywhere. So I guess you just have to decide like what is your product about. And sometimes it's just better to use other tools that, well, in 2 years, NATS really delivered on like stability, just easy to use. I can't remember a single breaking change in the API. So that's really something well, to think about, especially if you are building something that you think will last long. So I've been using NATS in several projects, not only in StorageOS. And yeah, I guess in some cases you would want to use gRPC when it's more or less like peer-to-peer between like one or two nodes. But like if you want to scale horizontally and you just want something in the background to do all the mesh networking, routing, and being useful in like those different scenarios, request reply and pops up, then yeah, I think NATS is currently your best choice. especially like from Go side. I hope that answers the question.
Cool. Thanks, Carlos. The next question was actually more about StorageOS. So someone was just asking if there's any exciting upcoming features that we should be aware of the rest of this year. I think it says, I've been aware of StorageOS for a while. I think you're still in beta. When do you anticipate the GA release? And are there some exciting features we should be aware of?
Yes. I think like one of the exciting features is embedded etcd, because we saw like quite a lot of problems with external console, and I think it just didn't make sense for us to keep working on that, because the product can be as good as you want, but if your dependency fails, then well, it's still your fault. So in our case, it's just about installing one container. We also have a discovery service that's helping with like initial cluster creation. But like mostly on our upcoming release, we focused on stability and production readiness. And our next few releases will be focusing all on just getting ready for production.
Okay. And I saw one other question come in. Someone was asking, how long did it take you to get comfortable using NATS and know that it was the right choice? And are there any updates to the documentation you think would be helpful?
Good question. Yeah, I think you can get running with NATS in probably a day, even less actually, because the server is really straightforward. It doesn't, especially like the default server that doesn't have like streaming, it doesn't have state, so you just use it for messaging. The API is really simple, like very good Matic. I would probably suggest focusing on just examples on their GitHub, because there are really good examples on how to like publish, subscribe, then request, reply, and just understanding the difference between like how to use queues, when not to use queues. Yeah, just trying out, and that's it. Yeah, that's what I think it's the main selling point of NATS, is just simplicity.
Okay, cool. Well, hey, Carlos, just want to say thanks for taking some time out of your day. I know in London it's kind of after business hours, so thanks for jumping on and showing us some more about where NATS fits in, and also some of the things you can do with StorageOS. I also wanted to just thank everybody who tuned in, and as I said, we will make sure to release the webinar and the slides publicly over the next day or two. And if anyone has any feedback or questions afterward, I saw Corrales put up his contact information. Feel free to reach out to him, or if some of you watching know me, feel free to reach out to me and I can connect you. But I'd just like to thank everyone for tuning in. And as I said, if there's a topic that you think would be particularly interesting or that you want to know more about that we should think about covering in the future, just let us know. We try to keep these fairly short and useful. And I'm sure we'll do another webinar in the next month or two. So with that, I'm going to close it out. And thanks again, Carlos.